welcome back. And so in this segment, we want to kind of summarize all of the stuff that we've been talking about in this lesson. And at the bottom of this picture, you see the equations that we've been using. So equation number 1 is going to be Kepler's third law. Equation number 2 is going to be the parallax law. Equation number 3 is going to be the photometry law. Equation number 4 is going to be Ven's law. And then finally, the equation number 5 is the one that we use in order to find the radius of a star, and so it doesn't have any special name to it. Now, if you look up above, you see a flow chart. And starting off on the left-hand side are all the things that we can measure with our telescope. So you'll notice that the very first thing is that you can measure the period of a object as the star as it's going around and around something. So we're basically measuring the wobble of the star. So that's the period. But we can also measure the parallax angle with our telescope. We can also measure the apparent brightness with our photometer, and we can also measure its spectrum by using a diffraction grating. So those are all the raw data that we get. Now you'll notice that there are 5 question marks. So what I want you to do is take those 5 equations and see if you can figure out where the equation goes. So you're only going to use the equation once, and you're going to need to put one of those equations for each of those different question marks. Okay, so you can put me on pause while you do this and think about where they should go. Okay, am I unpaused? All right, so now let's go over the answers to this. So the first one says that you're going to measure the wobble, and so that gives us the period. Okay, then underneath it, it says that we're going to use the parallax angle to somehow find the distance to the star. So which of our equations should we use in order to figure out the distance to a star if you know the parallax angle? Well, that's going to be the parallax formula. So that's number 2. So if we keep track here, we've got equation 1, 2, 3, 4, and 5. So we've just used up the parallax one. So that would be equation number 2. All right, now let's go a little bit further. If we know the period and if we know the distance to the star, how could we combine that information in order to figure out the mass of the star? So which equation would that be? Okay, that's going to be Kepler's. So Kepler's law was the one that allowed you to figure out the mass of a star if you knew its period and if you knew the distance. Now, we would take the distance, and then by using trigonometry, we would figure out the distance from the star to the thing that it's in orbit around. It's complicated, but at any rate, we're going to be using Kepler's law. So we're going to cross off number 1. So now we've gotten the first 2 top question marks. All right, now let's go down to the next one, and it says we measure the apparent brightness, the F, using our photometry. So if you know the distance to the star, and if you know F, what formula would you use to figure out the luminosity of the star? Okay, this time it's going to be the photometry equation. So that was equation number 3. So the photometry equation is the one that relates the L to the F to the R. And so now we've got that one. So now we've got 3 of our 5 question marks. And now we're going to go down to the next one, which is we're going to put a diffraction grating on there, and then by looking at where the lines are located at on the spectrum, we're going to figure out the temperature. So what formula will tell you the temperature if you know the colors, the lines, in a spectrum? Okay, and that turns out to be Ven's law. And so that was equation number 4. And now we're going to get that very last question mark, which says if you know the temperature and if you know the luminosity, what equation would you use to figure out the radius? Well, we only got one left, so you know it's got to be that very last formula. Okay, so there you go. So that's how astronomers measure various properties of stars. Okay, in our next segment, we're going to summarize the information that has been collected about stars.